In wave section, you know that we have total four chapters. In the first chapter, we have journal properties. In that, we have transverse longitudinal concept of the wave, and we also discuss the difference, that what is the difference between longitudinal and transverse wave. Then there is a concept of ripple tank. In the ripple tank, we discussed that waves can reflect, refract, and diffract. So reflection is very simple, that angle of incidence. We are practicing paper 4, theory paper, right? Because first paper is theory, so that's why we are practicing theory first. And in reflection, we know angle of incidence is equals to angle of reflection. And after that, in refraction, that is the bending of the waves. And final, we have diffraction. In diffraction, waves like reflect from the edges or the obstacle, just like in this diagram in question number 5 on the screen. So this is the idea of diffraction. We know that. So starting from this question number 5. So this is a scale diagram of wavefronts of red light approaching a gap in a barrier. And it is also important in electromagnetic spectrum. We studied about violet color and red color. And you all know that gamma rays have high frequency and radio waves have greater wavelength. So when we have greater wavelength, so it means less frequency or shorter frequency. But when we have like shorter wavelength, so frequency will be greater. So frequency, wavelength, both are inversely proportional to each other. So same sense, in the same sense, we know about red and violet color or blue color. So if we talk about red color, so red color have greater wavelength, less frequency. And if we talk about blue color, so blue color is opposite to the red, because blue color is close to the violet region, frequency will be greater. Okay. So it is approaching a gap in a barrier. And one more thing that we discuss, if you measure this gap and the distance between the wave fronts, so you can see that wavefront is greater than the gap. So what will be the formation of the wavefronts after passing through the barrier? Semicircle or the curved lines? What will be the wavefront after passing through the barrier? It will be a semicircle, right? Because we know the distance between the two slits is short as compared to the wavelength. Yes. So wavelength is greater than the gap. So when the wavelength is greater than the gap, so you will get semicircle waves. So in exam also you have to draw at least three semicircles. And one more important thing, that there is no change of medium. So you have to draw same wavelength, right? So distance between the wave must be same. So the distance between the waves, you can draw on the paper with the help of compass. You can draw, that will be like a regular pattern and easy to draw also. And at least three wavefronts you have to draw of same wavelength, right? Because wavelength is not changing. And in question, sometimes it is mentioned three. Otherwise, if it is not mentioned, so at least you have to draw three. Other than it's your choice, you can draw four, five, six. It's up to you. And in B part, it shows the same barrier and gap. A wave of blue light approaches this barrier. So now you can see we have blue light, and we already discussed that the wavelength of blue light is shorter as compared to the red one. So now you have to draw three parallel wavefronts before the barrier by yourself. You can see you have to draw three wavefronts before it reaches, and again three wavefronts when wave passes through the gap. So first of all, on paper, you can see it is mentioned, it is a scale diagram. So you can measure the distance, right? On paper, you know that in a screen, we can zoom in, zoom out, so distance may be vary. But on paper, you can measure the distance. Let's suppose if this is 2 centimeter, let's suppose. So if this distance is 2 centimeters, so for the blue light, we have to draw less than 2 centimeter. Okay, because the wavelength of blue light is less than the red color. So first of all, we have to draw three wavefronts. So you can see the distance between the waves is less than as compared to the first one. So this will be around like 1.5, 1 centimeter, whatever, it's your choice. So the only idea is that blue light has less wavelength as compared to the red. And now we know that this distance is, now in this diagram, wavelength is less than the gap, because when you got the printout of this paper, so on that paper, you will easily mark with the help of the ruler, and you will identify that the distance between the wave is less than the gap. So in this case, you have to draw the curved lines, right? Frequency and lambda is inversely, yes. Frequency and wavelength both are inversely proportional. So we have to draw three curved lines for this second case. So this is the only question, right? Okay. Question number 7. It shows some uses of electromagnetic radiations and different regions of the electromagnetic spectrum. Now you need to match them with the correct use or with the correct range of electromagnetic radiation. So first one is already done, Bluetooth headset with radio waves. What about the thermal imaging? We know that photography is for the visible light. Visible, yes. So photography is for the visible, and sterilizing definitely for gamma. Yes, right. And thermal imaging, we know that infrared emits from hot bodies. So this thermal imaging is also the part of infrared. Infrared thermal, right. So this is also simple. So we're done with the first part. In the second part, state the speed of the electromagnetic waves in vacuum. Yes, that will be speed of light, meter per second. Yeah, right. Speed of light equals to 3 exponent 8. Then a Bluetooth headset can be used to listen music on a mobile phone without the need of wires to connect to the headset of the phone. The headset uses frequencies in the range 2.40 till 2.48 gigahertz. So you have to calculate the wavelength of the radio waves when the frequency is in the middle of the frequency range. So frequency is in the middle. So first of all, you have to find out the middle. So to find out the middle, what we have to do, we have to take the average of this value. Okay. So we just 2.44 is the mid value, right? So this is the actual value that we have to use, the mid value. And gigahertz means 10 to the power positive 9. These all values are also like mentioned in the formula sheet that I shared with you. So you may take reference from that also. Now we just need to use the simple formula V equals to F lambda, or lambda is equals to exponent 9. 0.12. Okay, meters. Suggest why a Bluetooth headset only works well over short distances. So basically, we are using radio waves in wireless connection. So, and we also know that the range of the Wi-Fi, the range of the Bluetooth devices are limited. Yes. So definitely there are different objects in the path of that Bluetooth headset and the waves. And when radio waves travels from one point to another, so they get weaker. Their energy also loses, and they are passing through different walls, different objects. So definitely, it will block the frequencies or the range wavelength passing through that area. Get weaker. So this is another question. Okay. We have question number 5. It shows a road junction, a moving car, and a stationary truck. So car is moving, truck is stationary, and the road has high walls on each side. So it means they are not able to see each other directly. So the driver of the truck is at position X, as shown in the diagram. The car moves around the corner or figure 5.1 label a point Y on the road where the truck driver first sees the car. So you have to show at which point by using the point Y label on the diagram to show at which point the driver first sees the car. A plane mirror is placed at the road junction as shown in figure 5.2. So now you have to draw the ray diagram at the point where you think the truck driver first sees the car through that mirror. So what do you think at what point the truck driver first sees the car? So definitely when truck crosses the this junction, so then truck is able to see the car. Otherwise there is a wall, so definitely truck is not able to see before crossing this area. So definitely when truck reaches this point, definitely. So then truck is able to see this car when it crosses the wall. Otherwise, before that point, it is not able to see that car. And in the next part, there is a plane mirror, and definitely we know with the help of mirror, it is able to see with the help of reflection. And in the next part, they are asking the same, show how this mirror allows the driver of the trucks to see the car when it is at the position shown in figure 5.2. So what we have to draw? We have to draw angle of incidence and angle of reflection. And again, the angle of incidence must be equals to angle of reflection. So the angle coming out from the car, so let's suppose this is the angle. This is the normal line, or you can also draw this line. So the light coming out from the car strikes the mirror and then it reflects towards the truck. So truck is able to see the car with the help of the law of reflection. That angle of incidence will be equals to angle of reflection. Then we have structure of an eye, and the truck driver wears spectacles to correct long sightedness. And what is the meaning of long-sightedness? That a driver is able to see distant object clearly or close nearby objects clearly.
Only nearby, I think.
Okay. So basically, in long-sightedness, what happens? We are able to see distant object clearly.
Oh, okay. I guess I got confused for another turn. My
Basically,
bad.
yes. Basically, when we use these terms short and long, so it will define you. It is mentioned long-sightedness. It means you are able to see distant object clearly. When it is written short-sightedness, short means near, short distance. So you are able to see objects which are at short distance. And it shows figure 3.5.3 shows a blurred image of an object forms on the retina. You can see there it is a blurred object, blurred image because lines are not completely intersecting at a point. Any effect on the cornea on the rays of the light can be ignored, and image is formed on retina. Object is O. And in question on figure 5.1, show how long-sightedness is corrected by adding a suitable lens in the front of eye, continuing the path of the three rays of light until they meet to form an image. So you have to draw a new ray diagram with the help of three rays, and also you need to place a suitable lens in the front of the eye. So which lens we have to place? Because you can see light rays are not intersecting with each other. So which lens is helpful? Concave or convex? So definitely light is not converging. So we have to use converging lens, right? Because light is not converging. So we have to use another converging lens. So we have to use convex. Convex is converging. And we have to continue these lines to the lens. Center will be in the center without any change. Will slightly bend towards the eye and then further bend towards the retina to form image on it, right? So now image is going to be formed on retina. So all light rays merge at a single point to form an image. Okay, we have then question number 6 related to the lenses. A page of printed text is placed 18 centimeter from a converging lens of focal length 35 centimeter. Again, it is a scale diagram. You can use measurements on this diagram, and you have to mention these two principal focus. So that is already mentioned. Two principal focus are there, and five boxes, small boxes, are equals to 5 centimeter, both in horizontal and vertical. A length of 1 centimeter on the scale diagram represents the actual length of 5 centimeters. So this is important thing. A length of 1 centimeter on the scale diagram represents an actual length of 5 centimeter. So by drawing on figure 6.1, locate the image of the page produced by the lens and label it I. So you have to draw and locate the image of the page, label it with I. So first of all, we have to, okay. So basically in this, you can see there is a page of printed text that is placed at 18 centimeter from the lens. So this is the paper. So first of all, we have to draw parallel line and that will pass through the focus. So first of all, we will mark parallel to the axis that will pass through the focus. How to identify the features of the images besides it being real after lens or virtual behind object. Okay, basically, when you got all the light rays intersecting at a point, right, after the lens, because in lenses are transparent. So if object is on one side, so definitely image can be formed on the other side. So if you are getting image on the other side of the lens, other side means, let's suppose object is placed on left hand side. Normally, in all cases, object is on left. So your image must be on right hand side, and you can identify real image when all light rays are intersecting at a single point. If light rays are not intersecting, so then what we do, we extend these lines on the same side of the lens, like where object is placed. So then it is called virtual. Otherwise, if you are getting image on the other side of the lens, so that is real. And if light rays are intersecting, okay. Like in this question, we will see what happens. So we know that one light ray will pass from the center without any deviation, like this. So now in this case, you can see light rays are now moving away from each other. You can see their distance is continuously increasing. So definitely they will not intersect on the other side of the lens, right? Because focus is now very far away from the sheet. So definitely uh, we are not able to mark the third one. So now what we have to do, we have to trace them back on the same side to get the image, like this. We will trace them back on the same side, and from the center also. So you can see they are intersecting on the back side. It means on the same side. So this is called virtual image. This is the image I. So now you can see object image. Both are on the same side. So definitely it is virtual image, not real. And determine the actual distance of image I from the lens. Image I from the lens. So first of all, we have to count the boxes. So there are total 10, 20, 30, 39. 39 boxes are there. 39 boxes are there. And in centimeter, how to represent? We know that 1, 2, 3, 4, 5. 5 boxes are equals to 5 centimeter. And there are 39 boxes. So if you divide it by 5, so we will get answer 7.8 centimeter. And it is also mentioned that length of 1 centimeter on the scale diagram represents an actual length of 5 centimeter, right? So basically 1 centimeter on the scale diagram is represented by 5 centimeter. So it means that if you take this scale, so your value is 7.8 centimeter. But you can see it is mentioned 18 centimeter because one is small unit, like if you consider this one, so this is equals to 1 centimeter. So if you count like this, so there are total 39 boxes. 39 boxes means the actual length is equals to 39 centimeter. Okay. And if you take this scale of 5 centimeters, so according to this 5 centimeter scale, you will get answer 7.8. But they are asking about the actual distance. So actual distance, just like the object, you can see in the diagram, it is mentioned 18 centimeter. And there are exact 18 boxes from the center to the page of printed text. So it is equals to 18 centimeters. So that's why you are also getting 39 centimeter because there are 39 boxes from the center of the lens. Okay. Converging lenses can be used as a magnifying glass. State whether the image produced when a lens is used as a magnifying glass is real or virtual. Explain why. So now this is the question again. State whether the image produced when a lens is used as a magnifying is real or virtual. So we know that from the diagram, light rays are not intersecting at a single point. They are not like converging at a point. So that's why we have to extend them in backward direction and we got virtual image. So your image is virtual. And we know that we can define virtual image in two different ways. First one is that image is not obtained on the screen. Secondly, light rays are not converging. Okay. In part C, suggest how someone who is long sighted, okay, so someone is long sighted may benefit from using a converging lens. So basically, what is the problem with the long sighted? That image is or the light ray is focused at a long distance, right? So image, just like in the previous question, we got the image of retina with the ray diagram. So basically, light ray is focused beyond retina, like at a long distance from retina. So converging lens helps to focus those lines on retina or at short distance. Light rays do not converge on the retina. Converging lens focus light rays at allow them to converge on the retina. Yes, this is right. Okay. So in the previous question, we observed the example of long-sightedness. So in this question, they are asking about that. So this is the same reason that light rays do not converge on the retina. So converging lens focus light ray and allow them to converge on the retina. Or you can also use the word that light rays converge at long distance. So converging lens allow the light rays to converge at a short distance. So you can also use these terms in your answer. Okay, it's up to you. Okay, next question is related to, I think, total internal reflection. So there are two types of electromagnetic radiations are used in glass optical fibers for high speed broadband. State the type of electromagnetic radiation other than the visible light which is used in glass optical fibers. Okay, I got your answer, infrared. Because again, the same reason infrared have greater wavelength, so that's why we use long wavelengths for the transmission. And also you need to give two reasons why these two types of electromagnetic radiations are used in the glass optical fiber for high speed broadband. So basically, we know that yes, high rate of transmission is there because we use internets nowadays and we need very high speed of it. So that's why we are using these optical fibers to transfer data. So they can travel through long distance with very high speed and they can transfer data. The data transmission rate is also greater. And both type of electromagnetic radiation can reflect through the glass. If we talk about any other type of electromagnetic radiations, so those radiations will not reflect from the glass. They can easily cross the glass. So that's why we use infrared or the visible light, because we studied the concept of the refraction. So definitely refraction takes place in the visible light, and same happens with the infrared. And if we talk about gamma, we know that they have very high penetration power, so they can easily pass through without any change in direction, without any reflection. Because we also know about X-rays, X-rays can also penetrate. So if you try to pass X-rays, so they can easily just penetrate through the glass material, and definitely they will cross it without any reflection or refraction. In B part, the critical angle of the glass in an optical fiber is 45-degree. Critical angle is given and you have to find out the refractive index. So again, you have a simple formula to find out the refractive index, and that formula is n is equals to 1 over sine c, 1 over sine 45. So n will be equals to 1.4.
How was it 1.4?
Basically, this is like calculation. From calculator, you can calculate sine 45. So sine 45 is equals to,
Oh, okay. I'm opposite.
yes, 0 0.7 and then 1 divided by sine 45. That will be equals to 1.414 to 1. So round off 1.4. In part 2, it shows an optical fiber made of the glass described in part 1. Now draw carefully a ray of light in the optical fiber undergoing total internal reflection. So we know that in total internal reflection, light travels from dense to rare medium. So you have to show that angle of incidence, angle of reflection. And we know that critical angle is 45. So we also studied about total internal reflection, that your angle of incidence must be greater than the critical angle. It means your angle of incidence must be greater than 45, because you know there are 2 marks for this question. So you have to draw like this. Your angle of incidence must be greater than 45 because critical angle is 45. If you draw angle equal to 45 or less than 45, so you will only get 1 mark for representation of angle of incidence equals to angle of reflection. So keeping in your mind when light enters from here, so this is the normal. So you need to check your angle, that this angle must be greater than 45. Okay. So 1 mark for this value, to mark greater than 45. So you may draw with the help of the protector with the proper marking of the angle. So that will give you angle of incidence and angle of reflection greater than 45. Question number 4. It is an incomplete ray diagram showing an object O, a converging lens, and the principal axis, the focal point of the lens are each labeled F. And now you have to complete the ray diagram to draw the image formed by the lens. Label your image I. So you have to complete this diagram of the object, the light ray coming out from the object. So what do you think? What will be the representation of the image? At what point the image will be formed? On the same side of the lens or on the other side of the lens?
Same side as the object.
Same side, because you can see light rays are diverging. They are moving away from each other on the other side of the lens. So definitely image will not form on the other side. So this is the same case like the previous question we have. So it is going to be formed on the same side. So definitely that will be virtual. So again, we have to draw virtual image. So we can draw that ray diagram. So now they are intersecting, and when they are intersecting, so definitely that will be the image of an object. Okay. And now you have to circle three descriptions in the list which describes the image formed in the first part. So that is virtual, upright, and enlarged, right? So this image is enlarged, virtual, and upright. It means on the same side. In part B, state the name for the defect of vision that can be corrected by a converging lens. And in the previous two questions, we already observed this idea that long-sightedness can be corrected with the help of converging lens. Long-sightedness. And describe how a converging lens corrects the defect in part 1. It means they are talking about long-sightedness. You may find it helpful to sketch a ray diagram. So basically, in the previous two questions we already discussed, in one question, we discuss how to draw the ray diagram, how to complete the ray diagram. So you can take the reference from that part. That is this one. This is the same diagram that you have to draw. And for explanation, after that question, we also solve one more question that includes the detail. So in that, we also mention the detail that converging lens helps to converge the light at short distance on the retina. So that will form a real image, right? So this is a repeated question. We already solved this part, right? In two different questions, but you know that idea how to draw and how to write down the description. Okay, question number 7. A ray of light shines on the surface of oil. The refractive index of the oil is 1.47. So refractive index is given. On figure 7.1, draw the normal at the point where the ray enters the oil. So we have to draw normal and the angle x is 56 and we have to calculate angle of refraction. So first of all, we have to draw normal line. Then we have to draw angle of refraction. So normal line is perpendicular, we know it. And this angle is 56. So angle of incidence is 56. And when light enters into the dense medium, because oil is dense, so light bends towards the normal or away from normal. We know that light bends towards the normal and we have to calculate angle of refraction, and angle of refraction can be calculated with the help of the formula. This is 56 with the oil surface, right? So angle of incidence is equals to 90 minus 56, that is 34 degrees, right? So angle of incidence is 34 because we never measure angle with the surface, we measure angle from the normal. This is normal. So angle of incidence is 34. So we have to divide first the quantities. Sine 34 divided by 1.47. 0.38. So sine inverse 0.38 is equals to 22. So angle of refraction will be equals to 22. And state the approximate speed of light in air. So that is simple. 3 exponent 8 meter per second. Question number 6, two types of seismic waves are P waves and S waves. So basically, these seismic waves are the earthquake waves actually. So there are two categories of it, P waves and S waves. You don't need to know about their history and their detail, what are actually these. And the question is, state the types of wave that P waves and F waves can be modeled as. So basically, we know that there are two types of waves, longitudinal and transverse. So longitudinal and transverse. The velocity of P wave in the Earth's solid crust is 7.2 kilometers per second. Yes, actually it is knowledge based. We use two terms, longitudinal and transverse, and they are using indirect other terms, P waves and S waves. So that P waves are longitudinal and S waves are transverse, always. And velocity is given, frequency is also given. So again, we have to find out the wavelength. Simple formula V equals to F lambda. Sorry, we have to multiply it by 1000. So 7200 divided by 4.5, you will get your final answer. Okay, question number 6. A phone, a mobile phone network uses microwaves of frequency 1.9 exponent 9 hertz. Again, frequency is given. Speed is also given. So first of all, we have to find out wavelength. Same formula. So we divide these two quantities, 0.16, okay. And we have to state two reasons why microwaves are used for mobile phone signals. So why we are using microwaves for mobile wave signals? Because we have other types of waves also, but we are only using microwaves. So first of all, we know the reason that microwaves have greater wavelength and they can travel through long distances easily. And they can also penetrate through the wall. Yes, basically in our notes, we also mention the properties of microwaves, radio waves, X-rays, gamma rays, all those rays, individual properties are there in the notes. And I will again share that link so you may also check out from there. Or you can random search on internet also, you will find all these properties also there. Because you know that when we are like in a room or in any specific area, so we know that mobile tower is very far away from there and our door windows all are completely locked, but still we are getting phone signals, wi-fi signals. So basically we are using that because they are able to penetrate or they can easily pass through those obstacles. So that's why we are using that one. And also microwaves can easily be received with the help of a small antenna or like small aerials. Just like in the old TVs and old mobile phones, you know that they have very long antenna. So first of all, we have to open up that antenna because that antenna will catch up the signal. But in mobile phones, you know, there are no antennas. There are very like small sensors nowadays. They can easily catch and receive the signals. In per se, all mobile phone networks use digital signals to communicate with the phone. Describe with the aid of a diagram how a digital signals differs from analog signal. Okay, this is very like easy question. By reading this question might be feels that it is a something different one, but it is very easy. We know that when we are talking about digital things, right? So in like in computer, we studied in our lower secondary classes that computer uses binary language that is based on zeros and one. So that 0 and 1 is like a fixed value, right? Either 0, either 1. There is nothing between it. But in analog, right? In analog, like if you consider two different type of watches, like one is digital watch and second one is analog that have minute, hour, and second hand. So basically, in analog watch, what happens actually that minute hand or that hour hand have to move throughout the 360 degree in the watch. But in digital, you will get exact digit like 1, 2, 3, 4, 5. And if you take two different examples, like if you have two options, like options of the stair, that there is a stair to move to the first floor or and there is a ramp, like there is a slope. So there are two options. So when we are walking on the stairs, so there are discrete fixed values like first stair, second stair, third, fourth, fifth. There is no choice between 1 and 2. There is either 1 or 2. So that is called discrete values. But when you are walking on a ramp or on a slope, so that is continuous, right? You can stand anywhere on that slope. There is no fixed value, there is no fixed like position over there. So that is called a continuous, right? That you can even continuously slide on that ramp, so you will complete all the points on the ramp. But on stairs there is a fixed value, like if you place your foot on first, then you have to place on the second. There is no choice like 1.5, 1.3, 1.2. So that is the same difference between digital and analog. In digital, you will get discrete value like fixed defined values. And in analog, we got continuous values, just like the example of the ramp and the stairs. And the question is, you have to draw the diagram and also describe their differences. So we will draw the diagram first. We have to draw for the digital also and the on analog, and we know that they are like either regular pattern or either discrete pattern. So first of all, and this diagram is like AC and DC current also. The diagram we used to draw for AC and DC, for continuous values, you will draw like bar shape, because in bar shape you will get some specific value like discrete values. And in analog, we know there is a continuous pattern. So there is a continuous pattern in analog and there is like a discrete pattern in digital. So in digital signals, we have fixed values. And secondly, in analog signals, we have continuous values or variable values. And now we have to mention two advantages of using digital signals as compared to the analog signals. So we know that we are also using digital signals nowadays, because in old telephones we know that you have a dial, and to dial one you have to rotate or whole dial to one, then nine, then seven, then six, like this. But nowadays we have fixed numbers on the dial pad. So if you want to dial one, so you just press one. You don't need to do anything. So that is called fixed values, discrete values. So in digital signals, the advantage of the digital signal is that they can transmit data through long distances and with faster rate. So there is fast rate of data transmission, and data can be transmitted through long distance. And the digital signals can be regenerated and can be compressed. Okay, question number 5 is again related to the ray diagrams. Okay, in question number 5, it shows a block A, B, C, D made up of glass that have that has a refractive index of 1.5. The block has one curved side AB and three straight sides BC, CD, and DA as shown in the diagram. And there are right angles at C and D. The curved side A and B is 1/4 of the circumference of a circle that has its center at P. So this is the center P. A ray of monochromatic light enters the block through the curved side AB and strikes the side CD. At point P, some light emerges into the air and some is reflected, as we can see in the diagram. So the question is, what is meant by monochromatic? We know that mono means one, single. So basically the meaning of monochromatic is light of single frequency. And B part is explain why the ray of light does not change direction when it enters the block through side AB. So when it enters through the side AB, so this is side AB. This is a curved side. So they are talking about this curved side. So basically we know light ray only travels in a straight direction when it is passing through the center or either it is passing perpendicular to the surface. And if you draw a normal line from this side AB, so this is the perpendicular line to each curved side of AB. You can draw like perpendicular line everywhere because this is a curved line, and then curved surface or at the curved path. direction is continuously changing. So definitely your normal will also be like a different position from A to B on a curved path. So this light ray which is passing from air into the glass, so this light ray is on normal line. So that's why the angle of incidence is zero. There is no angle of incidence. So when there is no angle of incidence, so definitely there will be no angle of reflection. So that's why light is moving in a single direction without any change in direction. So light is passing through the normal, and angle of incidence is zero. Without any deviation. Okay, in part C, show that the critical angle C for the glass of refractive index is 1.5. Refractive index is 1.5 and we have to show critical angle is 42. So formula is simple. N is equals to 1 over sine C, and critical angle will be equals to sine inverse 1 divided by 1.5, that is equals to, we are finding N, sorry, C, right. So 41.8 degrees is round off equals to 42 degrees. Figure 5.1 shows that the angle between the ray of light and line AP is theta, where line AP is at right angle to side BC. So angle theta increases to 45 degree. State and explain what happens to the light that strikes P. So basically in question it is mentioned the angle between the light ray and line AP is theta. So they are talking about this angle theta, which is passing from AB and is striking at the point P. So angle theta is increases to 45. State and explain what happens to the light that strikes P. So we know that critical angle is 42 and this 45 is greater than critical angle. So when angle is greater than critical angle, so definitely it will reflect. So definitely light will starts to reflect because angle of incidence is now greater than the critical angle. So all light rays, the angle of incidence is greater than critical angle. And part 2, when angle theta is 45, the light strikes side CD. Describe what happens uh, when this refracted light strikes side CD. So this reflected light strikes this part of CD. CD, you know, this is bottom line. So again, it starts to reflect back. So it will reflect at 90-degree because again, the angle of incidence is already greater than 42. That is the critical angle. So that's why this light ray also starts to reflect. So again, all light ray is reflected. Okay, this part is also simple. V equals to F lambda. You have to calculate the value of X. Okay, if we consider this question, so it shows a wave crust and the direction of travel for a water wave approaching a barrier in the large ripple tank. And the wavelength of the wave is 1.6 centimeter. On figure 6.1, draw the direction of travel of the reflected wave and then three successive reflected wave crust. So this is barrier. So definitely from barrier, it will reflect back through the same angle. So this must be the direction of the wave. And we have to draw wave fronts of same distance, like of same wavelength, just like this one. So on paper, you can easily measure the distance and then draw the reflected wavefronts with the same distance. Then in part B, it shows an identical wave approaching a barrier. Now we have same wave approaching a barrier with a gap of 1.3 centimeter. So this is the gap of 1.3 centimeter. And again, you have to do one thing. You have to measure this wavelength again. And definitely, we can identify easily from the diagram that wavelength is greater than the gap. So definitely when angle is greater than the gap, so we have to draw semicircular waves after passing through the barrier. So we draw three successive wave crust after they pass through the barrier. And the last part frequency is given 4 hertz. We have to calculate the speed of the wave. So wavelength can be measured from this diagram, the help of scale, because in question, I think wavelength is not given. Sorry, it is given 1.6. So after multiplication, you will get the final answer of speed.
I got 6.4.
Yes. And since wavelength is already given in centimeters, so that's why your answer is also in centimeter. It's your choice. You can also convert into meter. So then your answer will be in meter per second. So figure 6.1 shows a converging lens and an object OX. The focuses of the lenses are labeled F. So you can see F is already marked on it. On figure 6.1, carefully draw two rays from X which locate the image of the object. Draw the image label it IY. Measure the distance from IY along the principal axis to the center line of the lens. So we have to measure distance from IY along the principal axis to the center line of the lens. So we know that again parallel line will pass through the focus and then center of the lens. So again you can see they are moving away from each other. So we have to extend them in backward direction to get the image of an object. So this is the image. This is IY. And then with the help of the ruler, you may measure the distance of IY
लैपटॉप
from
मर
the.
गया था।
Mhm.
9
Okay.
घंटे है मैक्स लाइफ।
So the distance of IY from the center you can measure with the help of the ruler. So that will be the exact distance of it. And state two reasons. You can measure the distance with the help of ruler on the paper. And two reasons why the image IY is virtual. So again, the same reasons it is not obtained on the screen. And object is placed very close to the lens. So that is the reason we are getting virtual image. Image cannot be formed on the screen. And it shows a ray of green light passing into, through and out of a glass prism. So it is a green light. And a ray of blue light is incident on the prism and on the same path as the incident ray of the green light. Draw the path of blue light through and out of the prism. So we have to draw for the blue light. So definitely blue is also moving through the same direction like this one. And definitely it will bend. And from the rainbow color sequence, so the wavelength of red color is the highest one, and it has the least. And according to the sequence, green light is greater in wavelength as compared to the blue one, right? So it means blue will bend with greater refractive index or with greater angle as compared to the green. Because if we have greater wavelength, so that light will pass with less bending angle or less refracted angle. But if light wave or light ray has less wavelength, so definitely it will bend with greater angle. So this blue light will pass somewhere from this point, and then further it will bend more as compared to the green one. And the reason is same, that the wavelength of blue is less than the green one. So this is the answer of this question.